Hello and welcome to this lecture on the file class in Java. The class java.io.file represents a file or a directory in the file system. The meaning I can get a lot of information about the files or the directories, such as how many subfolders are there, how many files are there, what they are, as well as creating a directories also is possible with this API. At the end of this video, you should be able to understand and use the class java.io.file to get information about the existing files and directories and use the java.io.file class to create directories. The class java.io.file is a representation of files and directory path names. Now, what is a path name? Typically, a user interfaces as well as operating systems, they use some system dependent path names, strings, to represent the files and directories. For example, you might want to say where is your file starting from D:, or probably from a network device. This class, which is java.io.file, presents a system independent view of the hierarchical path names, which means if you are using Windows, Mac or Unix operating system, it doesn't matter, the path names would look very similar. An abstract path name has two components. Number one, an optional system dependent prefix string. Now when we say system dependent, we are basically talking about OS dependent. For example, for Unix based operating systems such as Unix, Linux, Mac, slash is the one that is used, and for Windows it is two backward slashes. Now this is optional. Now you can also have a second part, which is a sequence of 0 or more string names. Now, why do we say a 0 or more? Because you can simply have slash to indicate that we are talking about a root directory. Now, the first name in an abstract path name may be a directory name, or in case of Microsoft Windows, it can be a UNC path names or a host name such as / server name. For example, if my computer name is suppose something like my laptop, I can say / my laptop. Now, if I want to connect to yours via network, I can say / your network, your computer, or probably your IP address. So that is what is the UNC name as well as a host name. Each subsequent name in an abstract path name denotes a directory. For example, under the server, you may have /A/B/C, where each of those would represent a directory. The last part of that may probably represent a directory or a file name. For local paths, you may use the Unix style path names as well, which means irrespective of whether you are working on Windows or Linux or Unix or Mac, you can always follow the Unix style path names, which is the forward slash. For example, I can say string path equals to D:// work/ sample.txt. Now, as you can see, the forward slash is the Unix style. Now, this works either in Windows or Unix platform. However, if you are using a Windows character such as backward slash, that works only in Windows but not in Unix platforms. The paths can be absolute as well as relative. What is absolute? Absolute path starts from a root directory or a drive like D:// or you can simply refer to sample.txt. Now, at the time of execution, from where your programs are being executed, the relative path will begin from that. So if you want to refer to a parent directory, you may use the .. or .. and so on. You can access them using dot and .. parameters. How do you create the file object? Now, java.io.file has varieties of constructors, but no matter which constructor you use, the file object will be immutable, which means once they are created, they cannot be changed. Of course, the only thing you can do is you can create another file object and discard the old one. Now, creating a file object can be done using the constructor file with a string message or string file name. For example, I may define a string path equals to D:/work, and assuming that that's a folder, I can now say file D equals to new file of that path. Now, we don't know whether that exists or not, we don't know whether it is a file, we don't know whether it is a directory, but we just created that. Now, it doesn't have to be already existing file or directory. We just represented this abstract name. Now there are a lot of useful methods through which you can now check whether it exists and what kind of file is that. Is it a file or a directory? Now there is a method called public boolean exists. Now as the name suggests, it just checks whether the file or the directory represented by that path, is it really existing or not, and there's only two choices, you get a true or you get a false. Now there is also is directory. That says, as the name suggests, is this a folder or a file? If it's a folder, you get it as true. If it's a file, you get it as a false. Now there is no other thing other than a folder and a file. Alternately, whatever that you mentioned does not even exist. Now there is also an opposite or a complementary function called isFile. So you don't have to use isDirectory and isFile together, because if it is not a directory, I'm sure it's going to be a file itself. Now let's take an example. We assume that D represents a directory or a file something, and then we check, does it even exist? If the condition is true, then we're going to go check, is it a directory? If it is a directory, we process that. Probably we want to see what files are there, what folders exist. Maybe we want to loop through each of the files to display them, or probably put into a list or something. And then else I can do something related to a file. Now note that I don't have to really check else if d.isFile, because if it's not a directory, it is a file. Now there are a lot of other useful methods to find out how much space is available. Now when you specify a directory name, it is basically going to tell how much of total space available in that particular drive, not the directories. So similarly, you have how much of space usable, which is nothing but free space. So basically the total space minus usable space would give you now how much have been consumed already. So if the path does not represent any valid partition or a directory, then you get 0 as the output. So how do we use this? d.get total space or d.get usable space. Now remember, the return values are long, so don't assign it to an int, because then it would give an error, because long is 8 bytes, int is 4 bytes, so that's going to be a problem. Now there are useful methods to find out attributes of a resource. For example, there is a method called canRead, which returns true or false. Basically, if a file is readable or not readable. If it is about a folder, then can I go and access all the files and subfolders of that particular folder? CanWrite is a feature or a property of a file or a folder to check if I can overwrite a file or can I copy some files into a folder. Similarly, there is a function to check is hidden that simply says, is this particular file or folder hidden? Now, before you use all these things, it's a good idea to check if d.exist returns true or not. Similarly, there is a method called length. Now that returns a long, which means it gives you a number representing how big is the file, number of bytes of a file, or probably a reservation for a directory, how many bytes have been reserved for a particular directory. How do we create directories? Now there is a simple function called mkdir that we can relate to the underlying operating system command called make directory or mkdir and md. Now the return value is a boolean here, because if d represents a wrong file name, or probably it represents a file name not a directory, and you are trying to create a directory with that name, there is no exception thrown, but it just says false. Now it's important to understand that there is no exception thrown. Now sometimes you might want to create a folder structure such that there is a hierarchy of folders you want to create. There is a parent, child, another child, and so on. If you want to create, then there is a function called mkdirs, meaning make directories, which again returns true or false. So only difference is that if there is a requirement of creating parent directories, this will do. And if there is a second time you run the command, it does not create, but it would simply return false. Both these functions don't throw exceptions. Now you can also delete a resource, the resource being a file or a directory. Now all you have to do is, if you create a path name and then create a file object, then you say d.delete or f.delete, where d or f represents a directory or a file. Again, if the deletion was successful, you get boolean true. But if you are actually, there is no such file or a directory and you are trying to call this, there is no exception, but it simply says false. So you can always do something like if d.delete, then tell the user that it was successful, else tell the user that probably there was no such deletion. You can also call one more method called delete on exit. Now the on exit here corresponds to the JVM. So basically when you call this particular function, the deletion does not happen at that point in time. However, when the JVM quits, at that point in time, the delete of the resource takes place. How do we rename? Simple, call the rename to and another file object. Now note that the file object is supplied as an argument, not string. So you need to create another file and then represent that as a file or a folder and then pass it on to this. For example, you can say D1 and D2 are two file objects representing two directories. One exists, D1, the other one is a new one. Then I can say D1.rename to D2. Now, when you get a directory by checking if d.is directory, now I can go and query what are the files in that particular directory, and the list of files come as a group, as an array, and then you can go and check each one of them, is it a file or a directory. So we can list with the same command files as well as subdirectories. How do we do that? There are variants here. There are overloaded list functions. The list function here can return an array of strings. Now each name in the string array represents the fully qualified path names to the sub files, which are files and folders which are found. Similarly, I can say give me list files, and the list files will give me an array of file objects. Now each file object contains the complete file information about individual files and folders found in this particular directory. So how do we get file names from that? Now when you have a file object, you can call getAbsolutePath method. Now this method returns a fully qualified absolute path of the file or the directory that it represents, and this would be system independent hierarchy. The getAbsoluteFile itself will give you a file object representing the complete path name. You also have getName, which only gives the resource name, ignoring the location where exactly it is stored. GetPath will give you the complementary of that, which means while getName gives you only the name, getPath ignores the name and gets you the location where that particular resource is available. Also, you have a getParent to indicate what is the parent directory that contains the current resource. The resource could be a file or directory, but what is its parent? GetParentFile gives you the file object representing the same thing. Remember, getParent returns a string that represents the path name of the parent, whereas getParentFile will give you the file object representing that particular file. Let's quickly summarize what we have seen so far. The class java.io.file can represent an existing file or a directory in the file system, or it can even represent a non-existing directory so that we can create one. Of course, we can even have a non-existing file, but of course, most of the methods would return no values because it doesn't exist. It has many useful methods for getting information, and it also has a lot of methods for creating a folder or even folder structures, set the attributes, or even to rename the file as well.